Hello, we are Team Anonymous. In this hackathon, we work on intelligent selection of spot instances for increased cost savings. But first, what's a spot instance? A spot instance is an instance that uses spare EC2 or VM capacity that is available for less than the on-demand price. Because spot instances enable us to request unused instances at steep discounts, we can lower our costs significantly. The hourly price for a spot instance in each availability zone is set by the cloud provider and is adjusted gradually based on its long term supply and demand. Spot instances are a cost effective choice if we can be flexible about when our applications run and if they can be interrupted. They are well suited for data analysis, batch jobs, background processing, and optional tasks. In this picture, we can see the per hour pricing of spot instances across different availability zones in AWS. For the C3.large instance type, it is cheaper to run our workload in US East 1B rather than US East 1A zone. Similarly, at a certain point of time, a GCP compute engine may be cheaper than these EC2 spot instances. In such a case, we would benefit by running our workload on the more cheaper GCP spot instance. Though the profit of choosing a cheaper instance would seem very small, in the long run, based on the number of tasks that are running and the frequency at which they are running, can have a compounding effect on the savings for the user. Apptio services make use of spot instances a lot. What if there was a way to find the cheapest alternative to run our workloads on so that we can reduce our expenditures? Our solution to that is an easy to use tool that will deploy tasks on an AWS EC2 instance or a GCP compute engine based on which costs less at the desired time. Let's check it out. Here is the user interface of the tool. We call it Spot Saver. At the top, the user will be able to see the total savings made by using the tool. We can select an instance property type from this drop-down to see the real-time graph of the prices that are there across comparable instances in AWS and GCP. For example, C4.x large and C2D high CPU 4. The chart currently accounts for one specific availability zone, but other zones can also be integrated. Below, we have the task list which shows all the info of the tasks which are in completed, running, or pending states. We can see the time taken by the task and the spot price at which it ran. At the time of launch, the EC2 cost was 2.5 cents and the GCP cost was 2.9 cents. So the total savings was $1.5 for this task. We can add a new task by clicking the Add Task button, provide a task name, select a minimum instance requirement, and the date time at which we want the task to run. If in case for a particular availability zone there is a cheaper alternative available to run, then we will pick the higher end, cheaper alternative for that task. Thus, with minimum user intervention, the user can just continue to get savings even when they are away and let the tool handle the deployment of the app or task. Here is a high-level architecture of our solution. We have the task manager, which allows us to schedule tasks to be run at a desired time. It also manages and monitors the current tasks which are either running, pending, or have finished. The cost monitor continuously monitors the current price of spot instances in AWS and GCP across the various availability zones. At the core, we have the spot savings calculator service, which uses the cost monitor to find the spot instance, which maximizes cost savings for the user. The automated deployment service is an intelligent service which is hooked up to an Apptio service and can deploy the workload on AWS or GCP using Terraform and start up a Docker container on that instance to process a job.